Hello, everyone. Today we are going to look into the problem Leetcode 300, the longest increasing subsequence. Given an integer array nums, return the length of the longest strictly increasing subsequence. So firstly, this is a very typical dynamic programming problem. It's with the name of LIS, this acronym. And we have a saying that all kind of algorithm with an acronym, you need to recite it. And then you will meet this problem again and again and again. First, we can go top down, like define dp and up to I. We get the longest increasing subsequence. So by definition, it's I'll check. Then I'll get subsequent up to I, up to J. I need to check. Gather the largest number and then return, because each one make sure I get the information of itself. So I want to return the max one. So this is the top-down version. Int object is not subscribed. Okay, it's the only one. Yeah. So from here we need to change. We can translate the top-down code to iteration, line by line. Up to I. J, and then I want to get suppose we gather the answer when we iterate the number. Because by definition, Fi is the longest increasing subarray up to I. Uh, okay, this is the iteration version. It's kind of like top down can be treated as the mathematical improvement, use mathematical induction to to say we can do the approval. And then when we come to the iteration version, or we say bottom up version, it's kind of like the engineering implementation. Like we build the solution space and then try to do the optimization from there. So here, from this version, we can do the binary search and greedy techniques to do the optimization with the candidate least candidate longest increasing subsequence. We can construct this subsequence according to when we iterate through the array. So from the candidate auxiliary, if we can't find an element larger than V, that means we need to expand the candidate array. Otherwise, we just raise the value of the candidate position. For now, it's pose. And then the length of the candidate array is the number of the length of longest increasing subsequence. So from here, we can maintain the value array, just evaluate the candidate longest subsequent array to see the value, whether the value meets the longest increasing property. So we can use data structure like weak tree or segment tree to maintain the relationship between like up to a number j, whether the longest increasing subsequent. So that's the different definition, and this definition is in the result value candidate LIS array. So let's go to this way. It's like because of the value is minus 10 to the fourth power to 10 to the fourth of power, and then we can do discretization. and then get the, so we don't use this one. And then we build the Finwick tree to maintain the maxed array, the maxed value in the array. Then we do the query. I just get the number, and then it reads to the number array, and then try to find so should be good. And then the other long story is the segment tree, but so it's kind of tricky and more overwhelming. But that's a solution, and I can practice this one to uh, to help myself to solidify the memory. It's different. It's segment tree from segment. This is for a segment tree, and then because segment tree. I want to see query. So this is a template of segment tree by update. Hmm, that's of otherwise to update the right side. Is the search range. Make sure LR is the up L is within the up L and up R. We just return the value in segment tree, which denotes the value in the range. Otherwise, we need to get the calculate the result and then get the result. We need to look into if we need to gather the information of left side. By doing so, we can have the correct answer. So we need to check all those operations accordingly. So 1, 2, 3, 4, max, not max anymore. We maintain the largest number in the array. We always have 1. That means the value was not updated properly. So I can look into the updated part. LR, I get the mean is I get the mean left side, and then update the right side, and then when you drill down left side, drill down right side, and then when we trace back, get the ops number here. It looks good for now. Oh yeah. So here, this you need to get the information of query. Now we are good to go. And then this is the segment tree version. For Finwick tree and the segment tree, the optimization on the value range is kind of like tricky. So maybe I use another video to explain the mechanism under the hood. So so much for today.